All right, we will take one of our last looks at the calendar. Katrina and Drew. Thank you. Okay, we just had test number 2. That was our last test up until the final exam. We have 3 days to talk about operations on algebraic fractions, and then 1 day to talk about equations that involve algebraic fractions. So 4 days of new material. Wednesday of next week is our review day. It is also the last day of the semester. The semester ends Wednesday of next week. Our final exam is on May the 20th, which is a Monday, 2 weeks from today. Katrina. So if you don't want to wait to find out how you did on the final exam or in the course, you can send me an email and I will give you both pieces of information as soon as I have them. Okay, so in terms of the test that we just had, the results were mixed. Some people did a lot worse on this test than they had on the previous quests. I know the material is challenging. The high grade on this particular test was a 94, second highest was a 93. I've got my answer key to this test floating around. It's right here. If anybody else wants to look at it, they can take a look at it during class or after class. I think it's a good idea to not just take the test and put it in a folder and not think about it, because anything you made a mistake on, we want to fix it before we make the same mistake on the final exam. Anybody else want to take a look at this right now? So we'll just send it around. You can send it back to Joe when you're done. Okay, and then one more thing that's different on this calendar from the last one that I gave you guys is that quest number 5 is canceled. It was supposed to be earlier in the semester, 3 snow days, pushed it back to the last day of the semester, and I didn't want to do that. So I have quest number 5. I'll hand it out either today or tomorrow, just so you can take a look at it. If you wanted to fill it in, I'm happy to grade it and not count it towards anything, but at least you'd have some feedback heading into the final exam. Probably what I should do is also print in my answer key to that, just so you have it. So I'll take care of that. What's that? So the way that this canceled quest affects your grade is the quest will just not exist anymore, which means each of the other quests are worth a little bit more. All 4 of the quests are worth the same. They're each just worth a little more than they would have been before. Good question. Okay. So I know that some of us really dislike fractions. I got bad news for you. That's all we're talking about for the next week and a half. So get used to it. So we begin here on page 68. And we're going to take a look at number 1 at the top of page 68. Joe. Okay, so here are 3 algebraic fractions, 5 over x squared, x over x plus 2, and then this monstrosity over here. They're called algebraic fractions as opposed to fractions because why? They have variables in them, that's all, right? 3/4 is a fraction, it's a number over a number. This is a plain old ordinary fraction. But if we have x's in the fraction, either in the top or the bottom or both, we're going to come up with this fancier name, algebraic fractions, right? And that's going to be the focus for our last 4 classes, is these things with x's in them. Okay, so have we used the word polynomial in this class yet? We have? Polynomial, trinomial, yeah. I mean, so we've looked at some binomials, like x minus 3 is a binomial. It's got 2 terms in it. We have seen some trinomials, x squared plus x minus 12. That is a trinomial, 3 terms. If we wanted to generalize this and say, well, it's going to look like x squared plus x minus 12, but maybe it has some more terms. Maybe there's an x cubed or an x to the 17th. We're going to call that thing a polynomial, right? So if we keep doing this kind of thing, we end up with something called a polynomial. And if you see a polynomial like this guy here, x squared plus 5x plus 4, divided by another polynomial, x squared plus 6x plus 8, that's what we mean by an algebraic fraction, right? So I know it's a lot of vocabulary. Essentially, algebraic fraction is just a fraction with x's in it. That's it. All right, we're going to go down to number 2 at the end in the back. Okay, Michelle, 3. Okay, so let's try this first one. 5 over x squared. We're going to plug in x equals 2. So this becomes 5 over, it's not necessary, but I'm going to put that 2 in parentheses. 5 over 2 squared is 5 over 4. In the last column, we want to plug in x equals 5. So here we get 5 over 5 squared, which is 5 over 25, which reduces to 1/5. Probably if I were smart, I would have reduced the 5s in the beginning, right? 5 on the top, 5 squared on the bottom, 1/5. Go ahead and do the other 4 blanks in this one. You're evaluating at x equals 2, and then also at x equals 5. Fill in the other 4 blanks and check with your neighbors. Thing, Evan.
We have a dispute about 12 over 0.
Yeah, 12 over 0.
I say you can't define
Undefined or 0. Those seem like the choices. All right, so first let's agree on the other ones. Everybody okay with the others? Half, 5/7, -3. So far, so good. All right, but this 12 over 0 is kind of funny because we've been taught from a very young age that division by 0 is poor, so we shouldn't do that. So what do you say the answer is when you have 12 divided by 0? It's undefined. That's just our name for something divided by 0. We just say it's undefined. What if you had 0 divided by 12? That's 0, right? So 0 in the top, it's okay, no problem there. 0 in the bottom is undefined, it's the end of the game. And it's not even like I'm just not telling you what the rest of the game is. I'm telling you, like, it doesn't matter how much math you know, dividing by 0 is the end of the game. You just can't do it, all right? So we see undefined, and we get this important thing here. We'll go to Jenny. Okay, so denominator can't equal 0, makes the thing undefined. Can the numerator, the one on top, equal 0? No problem. 0 divided by 12 is 0. Let's go here to number 4. Glenn?
what value of the variable is the fact x squared by x.
Okay, so this phrase again, not defined. What does it mean? Denominator equals 0. That's what not defined means. Right? So you see not defined, it always means denominator equals 0. So really what this problem is asking you is for what values of x is x squared minus x minus 6 equal to 0? That's the question. Yeah, it's a quadratic, so we can solve it. We have a lot of practice solving it. What formula could we use? The quadratic formula, right? It will give you the answer for any quadratic equation. Some of you guys are still very enamored with the quadratic formula, and that came out on the test. And one of my colleagues said something like, you live and die by the quadratic formula, because factoring is so much easier and so much more accurate if you have practice with factoring. Whereas the quadratic formula, there are so many ways to make a mistake. It is much more complicated to use the quadratic formula than to factor something simple like this. And so she gives really like hardly any partial credit if you choose to use the quadratic formula and you make a mistake when you could have factored and done it much more easily. So let's factor. Going back to our product sum idea, we spent a lot of time on that. Product is supposed to be -6. Sum is supposed to be -1. Definitely going to have x and x. What are the ways to make -6 as a product? -3 plus 2, 1 and -6. -1, +6. You can play with the signs. Eventually, you got to find one that adds up to -3. Sorry, to -1. -3 plus 2 is the winner. Yeah, the top part, this 5x, it doesn't come into the calculation at all because the top is allowed to equal 0. The top can be anything, but the bottom is the one that we really have to be careful where we step. You got to make sure that the denominator is not 0. And so we ignore the top. What's that? Is what more parabola? Well, the bottom could be a parabola. The graph of this is something quite more complicated than a parabola. Okay, so let's find the values of x. How much is x in the first parentheses? It's 3, and then the second one, -2. Much, much better than using the quadratic formula. Okay, challenge question. If you plug in, don't say the answer out loud, just think about it. If you plug x equals 3 in for all of these x's, what will you get? Don't say it out loud. If you plug x equals 3 in for all of those x's, what will you get? The top is 15, that's easy. The bottom, there's more work. But we know that this thing is going to be undefined. That's what we solved. So what are we going to get in the bottom? 0, without doing the work. That's the whole point, is that we, in the very beginning, we made the bottom equal to 0. X equals 3 makes the bottom equal to 0. You can plug in to check if you want to, but we shouldn't be surprised. We're going to get 0 down there. So that's it. So the fraction is not defined at those two numbers. Let's go to number 5. Melanie. What's the second half? So that's another place where the fraction will have a 0 in the bottom. Minus -2. Melanie. Okay, so we're going to reduce 24 over 54. What number goes into both? 2 goes into both. I'm going to write something. So normally you would just divide both by 2 and be done with it. I'm going to write it this way. 24 is really 2 times what? 12. And 54 is really 2 times 27. And then here's the idea. If you see 2 divided by 2, what do you get? You get 1. And that's kind of the point, is that you can bring those guys out and then they cancel. Most of the time when you get to this stage, you don't even bother writing the 2 over 2. You just say in your head, oh, it's 12 over 27. We can go even further, actually. Can you guys factor out another number? There's something else that goes into 12 and 27. I want you to write 2 more products. Something times something is 12. Something times something is 27. 3 times 4, 3 times 9. Right, 3 goes into both. And then what cancels? 3 over 3. And so our final answer here is 4 over 9. The fact that we had to do 2 and then 3 means that we weren't all that efficient. There's a bigger number than both that goes into 24 and 54. 6. 6 goes into both of them. Yeah. So much judgment back there. 24 over 54. Okay, one last time. Fill in the blanks here. 6 goes into both numbers. 4. So it goes in 4, goes in 9. What cancels? 6. And what do we get? 4 9s. Same thing we got before, but quicker. Okay, how much is 2 over 2? It's 1. How much is 3 over 3? 1. 6 over 6? 1. So on the next page, number 6. Where are we now? Ben. Keep reading. Yeah, FOO. FFOO stands for, keep going, Ben. Okay, thank you. Sevtab.
or reduce an algebraic fraction, we look for common factors in the numerator at x level. We cancel the common factors from the numerator at number simplify our.
Okay, so when you see 2 over 2 or 6 over 6 or 3 over 3, this is a fancy, each of these is a fancy form of 1. 2 over 2 is just a fancy way to write the number 1, right? We're going to call it foo-foo. It's going to come up a lot in these last 4 classes. So let's take a look at this part A right here. X squared minus 9 over x squared plus 6x plus 9, okay? We're going to reduce this thing. Just like you guys reduced 24 over 54 a moment ago. We're going to reduce. There are a lot of ways that look like should work and don't. You can try to cancel the 9s. If you want to continue to give me heart problems, you can cancel the x squareds. You can cancel a lot of things that look like they should be able to cancel. None of those things that we just crossed off cancel. Not a single one cancels. The only time you can cancel, we had 2 times 12 over 2 times 27. We canceled. What did we cancel? The 2's. What was the operation up on top? Multiplication. And downstairs? Multiplication. There is none of that in here. You cannot cancel unless it is multiplication. So even though it looks like maybe the 9's go away or the x squareds go away or some other nonsense that goes away, none of it does. Not until it's multiplication. So how do we turn addition and subtraction, which is what we currently have, into multiplication? We factor. We spend a lot of time factoring. Quadratic formula is not going to help you here. So let's do this first one together. We're going to factor the top. The top is a special formula. It's a difference of 2 squares, x and x. How are we going to make 9? With a plus 3 and a minus 3. X plus 3, x minus 3. Difference of 2 squares. Downstairs. Again, we need to factor. This is a product sum example. Two numbers that multiply to 9 and add to 6. 3 and 3. Plus 3, plus 3. So we factored. Okay, so I guess we kind of skipped over the big question, but here it is. Are the numerator and denominator in factored form? Initially, no. If the answer is no, you cannot reduce until it is factored. So step 1 here, after you answer the question, factor numerator and denominator completely. That's what we did. Now that we've factored, what's the operation in between these parentheses? It's multiplication. And when it's multiplication, I can cancel if I see a foo-foo, a fancy form of 1. Do you see 2 things that are exactly the same upstairs and downstairs? Yes, x plus 3 is a carbon copy of x plus 3. But you might be wondering, well, how can we cancel there when it's addition? And I said a second ago, you can't cancel anything in here because it's addition and subtraction. But it's not really addition. If you, maybe we'll block this out. I'm not even going to look in there. I don't really see what's in there. What I see is the red thing is being multiplied. And then the scratched off red thing is being multiplied, right? And if those 2 red things are exactly the same, then in my mind, I'm thinking, oh, it's just like this 2 times 12 over 2 times 27. If I see 2 things being multiplied that are exactly the same, I get to cancel them. Well, that's what I have here. Even though there's addition inside the parentheses, I don't even see it. All I see is a carbon copy of 2 things, one on top of the other, and multiplication. And that's when I can cancel. It doesn't have to be in parentheses as an entire numerator. If it were something like 3 times x squared times y times 4 minus y, that's factored because all these operations here are multiplication. How about, so let me write down what we have left. X minus 3 over x plus 3. Can we cancel the x's? No. It's not multiplication anymore. There's not a single multiplication symbol up here. It's now subtraction on top, addition on the bottom, and unless they're carbon copies of each other, you can't cancel. Can we cancel the 3's? No. This thing right here is simplified. That's our final answer. It's done. Even though it's so tempting to try to cross off some x's or to cross off some 3's. We can't go any further. Okay, let's move on to the next example. So the next example is kind of buried here. It's part B. 3x plus 12 over 6x plus 24. Can we cancel 3 and 6? Can we cancel x and x? Can we cancel 12 and 24? None of the above. Not until it's multiplication. The way you turn it into multiplication every time is to factor. 3x plus 12 is not a quadratic, so it's not going to be one of these like two sets of parentheses like the quadratics we're used to. What number goes into 3 and 12? 3. This is a factor out the greatest common factor. See if you can fill in the blanks. Factor out the greatest common factor downstairs as well. What's left on top in the parentheses? X plus 4. Yeah. What can we factor out on the bottom? 6. And what comes out? X plus 4. Do we have multiplication? Yes. Things are factored. We're allowed to cancel. We're allowed to cancel the 3 and the 6. What does it become? Just 1 and 2. And what about the x plus 4s? Cancel those as well. They're exactly the same. So the final answer here is 1 over 2. Questions on that? You like these? Yeah. All right. All right.
Clearly, you can tell where it points.
No, if the final weren't already printed, I'd be right there with you. But it's already printed. I can't. All right, let's take a look at part C. 2 plus x divided by 2. Can we cancel the 2's? No, it's addition. It's no good. We need to turn it into multiplication. So you try to factor. Can you factor the top? No. Can you factor the bottom? No. So can we do anything? No. This is already simplified. It's really tempting on a test to say, well, Ian's asking me to simplify, so I better do something, and then you start crossing off stuff that you can't. And you end up with the answer of x, or the answer of 1 plus x, or something like that. Yeah. Okay. Let's take a look down here. All right, so then the most important thing here, factor first. Factor first, all right? Okay, let's go down here to number 7. Number 7, we're over here to Tenzin. You can not read that part. Okay. Okay, so let's just plug this in. X equals 10 for both of them. So upstairs, 10 minus 3. Downstairs, 3 minus 10. 7 over -7, which is -1. Do the same thing. Plug in -5 for both of those x's. And we get -1 again. Okay, so it turns out this fraction is always -1. Doesn't matter what value of x you plug in, it's always going to be -1 because the top and the bottom are going to be subtracting the same things but in the other order. 10 minus 3, 3 minus 10. Doesn't matter what you get, you're going to get the same number except one will be positive and the other will be negative. So in general, we go down to number 8 on the next page. Teresa. Okay, so that's going to be important. Maybe we'll highlight that. A minus B over B minus A is equal to -1 all the time. Okay, so we're going to try simplifying this one here. 64 minus x squared over x squared minus 6x minus 16. What do we do first? Factor. Factor first. Okay, when we factor upstairs, some people made a small mistake on this on the test. So I see another difference of two squares, right? 64 is a perfect square, x squared is a perfect square. 64 is going to come from what two numbers? 8 and 8. And x squared is going to come from x and x. But you got to put them in the right spots. Whatever comes first here has to come first over there. 64 is first. It needs to be 8 first. X squared is last. The x and x have to come last. What goes in the signs? 1 plus, 1 minus. Doesn't matter which one you put first. And I know that on the test, some people swap the order because they don't like to see x second. But you don't have any choice. It is what it is. X is second in this problem. You could put negative x plus 8. You could do that. But whatever you do, there's going to be a negative in front of that x, and we have no control over that. Let's go on the bottom. We're going to factor this guy. So this is another one of these product sum ideas. Two numbers that multiply to -16. So we could do 4 and what, -16. So 4 and -4 would work. Other numbers that multiply to -16. 2 and -8. Or -2 positive 8. And when I add 2 and -8, I get -6. This is our winner right here. So it's x plus 2 times x minus 8. Now what's the basic operation upstairs and downstairs now? What's the operation? Is it addition? It's multiplication. We have factored. That was the big first step. Now if you see a foo-foo, you just cancel it. Do you see two things that are exactly the same as each other? No, there's nothing that's exactly the same. But there is something that looks like a minus b over b minus a. You want two things that are just in the reverse order. And do we see 8 minus x and x minus 8? They're the same, but just one is the reverse of the other, right? So yes, you can cancel them, but you can't just cancel them without paying for it. What is it equal to? It's equal to -1. The whole thing becomes -1. So let me write our answer and then we can take any questions. So there's a -1, and then I'm going to put my fraction, 8 plus x over x plus 2. You could put that -1 upstairs or downstairs or in the front. Really a lot of places you can put it. You can't use an I because it's not a square root. Okay, how are we doing with this idea? Same thing but reversed. Do we recognize that? 8 minus x, x minus 8. And so when you see them, you cross them off, but you got to pay for it. It's not a foo-foo. They're not exactly the same. So you cross them off and you change it to -1. Melanie wants to know, can we put that -1 downstairs? Yes, you can. So I can put it down here if I wanted to, or I could put it upstairs. That's fine. Or you could put it in the front, which is where I put it. I could just put it as a single negative. A lot of different ways to write it, but you got to get that negative in there somewhere. Any questions before we move on? That's it. There are other ways to write this. Like I said, you can put the negative. No, you just put a negative, which is the same. That's what -1 times does. It just sticks a negative. So if you prefer, you're allowed to write this in other ways. We said we could take that negative and put it upstairs. And so I could take a -1 and distribute it through upstairs, and that makes the top -8 minus x, distributing a -1 through. It doesn't change the bottom. The -1 is either up or down or in the front, but it's not in both. So I'll circle this answer is good, this answer is good. There are a lot of ways to write it. Okay, let's go to number 9. Dan in the front. Okay, how do we multiply two fractions? Yeah, so the general answer that a lot of students say is you multiply across, which is correct. But the better answer is what Michelle said. Can you repeat it? No, that was good. First cancel, and then multiply across. Anything on top with anything on the bottom is allowed to cancel. So one way to do this is to multiply across. 4 times 18, probably not all of us know what that is just off the top of our heads. It's not wrong to do it, but there's a better way than just multiplying across, and that's the first cancel. So let's cancel. 4, all right, so again, what's the operation here? Multiplication, which means we are allowed to cancel any numerator with any denominator. 4 goes into 8 how many times? 2, so that's a 2 and a 1, right? And then in a different color, 18 and 9 reduce. 2 up there and a 1 down there, right? And then that works pretty well because then we have 2 and 2 and they both cancel and we just get 1. So that's the answer. The answer is 1. But the important thing here is to recognize that when you're multiplying fractions, yes, you go straight across, but better is to cancel first. Cancel first, because then you don't have to deal with 4 times 18. And it's going to be even worse if you don't cancel first with what we're about to do. So you really want to cancel first, then multiply across. All right, so let's come back to, we'll skip the division for just a second. We're going to come down here to 11a and b. We're multiplying two fractions. Again, the idea is to cancel first and then multiply straight across. First, I'm going to make this a fraction by dividing by 1. What's the operation in part A? It's all multiplication. Is there any factoring that we can do? No, there's no addition or subtraction at all. It's just straight multiplication. Compared to part B, see all the subtraction and addition? That one we're going to have to do a lot of factoring first to turn it into multiplication. We'll do that in a second. Well, let's come over here. Instead of just going straight across, first we're going to cancel. 15 and 35. What number goes into both? 5 goes into both. 3 upstairs, 7 downstairs. Carry what? So let's cancel some x's. Upstairs we have x squared. Downstairs we have x. How many x's are left when we cancel? Just 1. Up or down? Up. So cross off the x squared, it becomes x. Cross off the x downstairs, it disappeared. Can we cancel y's from top and bottom? No, there's no y's upstairs. Cancel any other numbers? No, so all that's left to do is multiply across top and across the bottom. 3 times x times 3, 9x. 1 times 7 times y squared, 7y squared. Done. Any questions on that one? Okay, part B. The main operation here is multiplication, so that sounds good. But the terms themselves, the numerators and denominators, are not factored. So we got to factor first. That's what we've been doing for most of today. So upstairs, we're going to have fraction here, parentheses, downstairs, more parentheses, times. Here you're going to have one set of parentheses, and downstairs, one set of parentheses. That's what the shell is going to look like. Take a minute with your neighbors and see if you can factor. All 4 of these different things have to get factored, both numerators and both denominators. Go. So there's a lot of work to be done in terms of factoring. Again, the quadratic formula is not going to help you with these, so you really need to be good at factoring. If you're not there already, you got to go back and review how we do all this different kind of factoring. Now we're looking for things that are the same. What do we see upstairs and downstairs that's the same? 2y plus 1. It's exactly the same in both. Now there's something else that's not quite the same, but it's almost the same. This 2 minus y and this y minus 2. It's that same trick where it's the same thing but reversed. So when we cancel them, we pay for it with a negative 1, right? You see 2 things that are the same on top and bottom but reversed. Cross them off, put a negative 1. You can put it on the bottom, on the top, either fraction. You can really put it anywhere you want to. It's just negative 1 somewhere. So let's look at what's left and see if there's anything else we can cancel. Let me see here. All right, so how about this right here? This 2 cancels with this 2? No. One of those 2's is actually ready to cancel, but the other one is not. Which 2 is in a good place to cancel? Is the one on the bottom, because the one on the bottom is right next to what symbol? Is multiplication. So the 2 on the bottom is ready to go. But this 2 up here is not ready to go. It is near some subtraction. No good. We can't cancel those guys. We'll get rid of that. So maybe we can cancel something else. How about this y right here with the y upstairs? No. How about this 2 with this 2? No, 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 no. So again, unless it's either 2 carbon copies of the same thing or that fancy trick where they're identical but reversed, don't cancel. We're done. So we just have to write the answer. Equals. Upstairs, I see a 2y minus 1, and I see a y. Downstairs, I see a 2 plus y, and I see a 2. What's the only other thing we see? Is a negative 1. I'll put it downstairs. You can put it upstairs. You can put it in the front of the fraction. Evan. Oh, you can distribute. You can distribute upstairs and you can distribute downstairs. That's fine. Generally, factored form is the best kind of form for something to be in, so it's not wrong to do it, but there's really no motivation to do it. Okay. All right. What's going on with part C? How is that different from part B? It's division. So let's go back and remind ourselves how we do division with normal fractions. We're going to do number 10. How do we divide 4/9 divided by 2/27? Does that sound familiar? Copy the first fraction. We change division into something much more familiar, which is multiplication, but then you pay for it. 2/27 becomes flipped over, 27 over 2. I used to work with somebody who was taught keep, change, flip. And that's what he knew about dividing fractions. You keep the first one, you change division to multiplication, you'd flip the second fraction. Sam. Skip, flip, and multiply. So however you can remember it, we've got to change division into multiplication. Okay, is it wrong to do 4 times 27 and 9 times 2? It's not wrong.
It's just,
It's unnecessary. 4 times 27, anybody? Exactly. So, all right, it's 108, put the calculator away. But let's cancel. What cancels here? 4 and 2? Cross them off and make 2 and 1. How about 27 and 9? So that's a 1 down there. 3. And now it's just 2 times 3. 6. And it's a lot better to do that than to do 108 divided by 18, which is 6. It's not that difficult with a calculator, but what we're about to do is going to be something with x's in it. The calculator isn't going to help us. So we really do need to make sure we cancel before we multiply. Melanie? Okay. Let's take a look at part C. All right. So first thing to do is change division to multiplication. What about that first fraction? Keep it or flip it? Keep it. A squared plus 2a minus 15. Divide. I'm just copying this fraction down. Division becomes multiplication. And the second fraction, what do we do with it? Flip it. No, you don't change any signs. You just literally flip the fraction over. Okay, before we cancel, what do we need to do first? Factor. How many things are we about to factor? 4. Lots of factoring. So factor 4 things. You're going to have lots of parentheses, 2 for each. Okay, let's come back together. How are we doing with factoring? So remember I had said factoring was really something we were going to do a bunch. If you weren't good at it back then, you're about to get double penalized for it. You already got penalized on a quest and or a test. It's coming back to haunt you. Again, the quadratic formula is not worth anything in these problems. Got to be able to factor. Assuming we factored it, now it's a matter of canceling because it's all multiplication. So a plus 5 cancels. A minus 3 cancels. A minus 2, a minus 2 cancels there. Notice that it doesn't matter which fraction it's in. You can take 2 things that are in the same fraction. See the purple? They can both cancel. And you can see 2 things in different fractions, like the blue. Doesn't matter where they are. Anybody on top with anybody on the bottom that's the same. Can we cancel the a's? Yeah, it's so tempting. A lot of people would say, oh, cross off the a and you get negative 7/3. Can't do it. So the answer is a minus 7 over a plus 3. Done. You can put 1 if you want to. Every time you cross something off, you can put a 1. Okay, let's take a look. I think there's actually a typo in the next problem. We're going to change the next problem a little bit.
Okay, good.
Because otherwise there's nothing to do. So let's cross off that. And it's all right, 10 is good. And how about some m's? M squared. Okay. Yep. Just change it. Just feel free on the final exam. Ian, this is a typo. Okay. Here's the deal. Are you allowed to cancel 5 and 25? No. All right. Can we cancel m cubed with m to the 4th? No. What do we need to do first? Factor. You need to factor the top. So let's factor the top. It looks crazy, which means that probably there's a greatest common factor that we're going to take out. What number goes into everything upstairs? 5. How many m's are there in everything upstairs? Is 2. You can take m squared out of everything. So see if you can fill in the blank after we factored out 5m squared. It's great. Okay, 25m to the 6. What does it become? I think it's 5m to the 4. All right, and then the next one minus 3m squared. And then what? Plus 2? Okay. And now there is a time symbol right there, which means anything in the front there is ready to cancel. So let's cancel. What can we get rid of? So the 5s I'm going to cancel. In another color, I'm going to cancel the m's. What happens? M squared over m cubed? Yeah, it's a single m just downstairs. I notice the negative is still there. So yeah, so maybe it's better to put -1 is what's left over. 5 and -5 cancel and make a -1. Yeah. So let's write our final answer here. Upstairs is just what's in the parentheses. It was M3 on the bottom and M2 on the top. And when we cancel, there's 1 M left over downstairs. Yeah, -1 times M on the bottom. If you could factor the top further, then you should. I don't believe that it does.
Looks like it would. I know that the 5 and the 2.
Yeah, so you can try. I mean, you can try funky factoring, or you can do a trial and error thing, or the box method. I don't think it factors. But if it does, then you should factor it. But I don't think it does. Any questions on that one? Okay, so the group thing is on the next page. We have about 12 minutes. There are 6 problems. See if you can get those 6 things done in the next 12 minutes.